Hello. We're back again with another discrete time video. And I hope you guys had a wonderful Halloween. Spending time with the family. But we're just gonna start things off a little bit different. I'm just gonna tell us a quick knock knock joke. Are you guys ready? Knock knock. Who's there? Lettuce. Lettuce who? Let us in and you will find out. That's the joke. Get it? Let us in. Let us who? Okay, but we're just about to get started real quick. So here we have our function, and this is our graph right here, where we have, I color coded it, but you guys can do that yourself. So essentially, our goal is to find the impulse response h of n for this system, where this system is right here, h e to the j omega. So what's important to know? It's important to know, understand the gain. The gain for this system is 1, and the region that we have is negative pi over 4 to pi over 4. So in order to find the impulse response overall, we're gonna use the sinc function. So sinc function is down here, but we're gonna break it down. So here we have our equation h of n 1 to the 2 pi, with the integral of negative pi to pi, right, of the system times e to the j omega. Now, since we know more about the system, by color coding this part of the system, we are able to understand it a lot better. Where we have for the region negative pi to negative pi over 4, the region is 0. From negative pi over 4 to pi over 4, the region is 1. And from pi over 4 to pi, the region is 0. So when we put it into our equation, we can easily understand that this region will equal to 0 because the system right here is going to be 0, and the same thing follows right here. So we can quickly cancel these out, right? So now our focus is on the red section, right? So that's how the red section comes about. Well, what we're going to do, we're going to solve for the integral, right? We're going to solve for the integral and then plug negative pi over 4 and pi over 4 for omega. Once we do that, we can easily we could easily use some of our properties. So now since we can quickly see that this property right here comes out to 2j sine pi over 4n, and we could quickly cancel those out in here with the sinc function, right? Because of the sinc function, we could easily come up with our impulse response being sine pi over 4 over pi n. So that's essentially how we find the impulse response to the system. For part B of the problem, we're going to try to find the new impulse response, and for C, we're going to also try to find a new impulse response as well, where we have two different equations, right? So for part B, we can easily understand that we already have h of n. H of n is the impulse response, which we got from part A. We plug it into our equation, and by converting it, we can easily understand that we have a delay, right? We have a delay of omega minus pi to the n. That creates a delay, like a shift in frequency. So when we plug it back to the system, we can draw it out because of the shift, where we have minus 5 pi over 4 to the 4, minus 3 pi over 4 to 4, and 3 pi over 4 to 5 pi over 4. The reason why we have that region is because we're minusing it by pi, which is an entire shift, essentially think about it as by 1. So, and for part C, it's the same thing again, where we essentially have a shift in frequency. when you look down through the steps, you know, following it, we have the same sort of shift, but we really have -3 pi over 4 to -pi over 4 with a gain of 1, and pi over 4 to 3 pi over 4 with a gain of 1 as well. But overall, that's essentially how you solve for the impulse response and solving for the new for different impulse response where we have different equations using our original system. Thank you for being part of the video, and like and subscribe. Thank you.